Okay, continuing with the combustion reaction from section 7.2, chapter 7. So we talked about how it's a carbon-containing compound. You see here methane and propane, both gases at room temperature. And this is kind of like gasoline burning, all right, or the candle burning. It's taking up oxygen from the air. That's how burning happens. You need oxygen for combustion. And the carbon and the oxygen combine. So you're getting an oxide. Carbon is getting oxidized. And so is the hydrogen. Hydrogen is becoming water. All right. So the key to combustion reactions is that how do you balance it? All right. So the way you balance these combustion reactions is going left to right. Start by balancing the carbons, then the hydrogens, and finally the oxygens. All right. So you have one carbon, four hydrogens. So you need two waters to balance out four hydrogens. And then you count up the number of oxygens on the right side. That's 2 plus 2. So you need 4 oxygens on the left. And so you put a coefficient of 2 in front of the oxygens. All right. So you follow the exact same way to balance this reaction as well. So to summarize the reactions that we looked at, combination where you have a couple of reactants, single product. Single reactant for decomposition giving you one or more products. Single replacement is where one element is pushing out another in a compound, all right? So it's element, compound, compound, element. Double replacement is exchange of dance partners. You see the metal of one coming together with the anion of the other one, and then the metal of the second one coming together with the anion of the first one. All right. So calcium and chlorine forming calcium chloride, that's combination, single product. Iron sulfide breaking up into iron and sulfur, that's a decomp. Copper pushing out silver from silver nitrate, that's single. And then barium, extreme left to extreme right, barium sulfate comes out as a precipitate, and then the potassium and the chloride come together but stay in solution. And then you have combustion, where you have a carbon hydrogen product, a compound called as a hydrocarbon, reacting with oxygen from the air in the presence of heat, forming carbon dioxide, water, and a lot of energy. So propane heater, fireplace, wood stove that is used to burn fuel. You need good ventilation, all right? Because if the oxygen supply is limited, there's not enough oxygen, then what will happen is instead of carbon dioxide, carbon monoxide will form. This is called as incomplete combustion, all right? And carbon monoxide is poisonous, which is why you need good ventilation, where you have your heaters in or your fireplace or your wood stove. Otherwise, it can be very dangerous. So carbon monoxide is hard to detect because, again, it's a colorless, odorless gas, very toxic. Hemoglobin is the transporter of oxygen, all right? So hemoglobin is the protein in blood that transports oxygen to the cells. But it has a high affinity for carbon monoxide. So when there's a high amount of carbon monoxide that is being breathed in, then what happens is it pushes off the oxygen and it attaches itself to the hemoglobin, all right? So therefore, the cells are oxygen deprived, and that will lead to the person slowly losing perception and losing the ability to move, and in extreme cases, it can lead to death. All right. So when a person, the hemoglobin bound to the carbon monoxide reaches 10%, then the person experiences a shortness of breath, headache, drowsiness. 30%, headaches and nausea and dizziness. 50% becomes unconscious. And if not treated immediately with oxygen to displace out all the carbon monoxide in the system, then that person can die. All right, so identify each reaction as a combination, decomp, combustion, single or double replacement. Okay, so here you have element, compound, compound, and element. So that's single. This is double because you have the sodium and nitrate coming together, silver and the sulfate coming together, exchange of dance partners. This is two reactants, a single product combo. And then here you have a hydrocarbon and oxygen forming carbon dioxide and water. All right. So if the products are carbon dioxide and water, that is a combustion. Identify each as combination, decomp, combustion, single or double. All right. So two reactants, one product, that's combination. And then element, compound, compound, element, that's single. And then you have a hydrocarbon, you're getting carbon dioxide and water, that's a combustion. And this is exchange of dance partners because the lead sulfate is coming out, precipitate, the two in the middle are coming together. And then this one is breaking up. Potassium carbonate is breaking up into two products. So this is a decomp. And we will stop here.